Hey everyone, here we have a good stats question for Psych 2021. Let's read it and see if we can figure out what we need to do. So a particular drug is about to be patented, and the company thinks it reduces depression levels. A simple random sample of n equals 16 patients with moderate depression are given the drug, and over a month, depression levels decrease to on average 8.2%, when depression levels under basic treatment are assumed to decrease following a normal distribution with mean 7.4 and standard deviation 0.9%. At a significance level of 0.05, is there evidence that the drug has a positive impact over basic treatment? How about at 0.10? Okay, so there's a lot to take in there for sure. Let's kind of work through it and see if we know what to do. So first I would say there's a significance level. And is there evidence they're asking for? So we know there's going to be some sort of hypothesis test here. So we're going to be following those steps. That's great. Now, what else do we have? We have our sample size, n equals 16. We've got on average 8.2%, so that looks like the sample mean. And then we've got 7.4 and 0.9, the normal distribution with mean 7.4 and 0.9, so those must be the population parameters. Great, so we look pretty good. Remember, before we go and do a significance test, we say, okay, do we have sigma, or the population standard deviation? In this case, yes, we do. It's 0.9, so we know it's going to be a Z test. So let's go ahead. So step 1, state the hypotheses and alpha. Our null hypothesis is always going to be mu equals something, and in this case, we always want it to be mu equals the status quo, so we just take for granted that even this drug, without us kind of taking any data into account, we're going to assume it's just like normal treatment, and on average, it will reduce 7.4%. Depression level 7.4%. In contrast, we're sort of guessing, or our hunch, or what we want to see if the drug company's telling the truth. We want to know if really it's actually greater than 7.4. So does this drug have a bigger impact than normal treatments? Great. Our alpha level, we're going to start with 0.05, and we can always compare it to 0.10 afterwards like they ask for. Okay, step 2. I'm going to change color for each step. So step 2 is state your rejection region. So let's just draw a little picture over here because it always helps. And we know that this is a one-sided test because we're only worried about whether mu is greater than 7.4. So I want 5% to be in my tail, and this is going to dictate the Z value, the critical value that we look. So there's 0.05 of area under the curve to the right, and if we go and look this value up in our Z table, it's a very common one. This is 1.645. You can find that from the Z table. So I call that Z star, our critical value. So then we can simply say for step 2, we will reject HO if Z is greater than 1.645, because that'll put it in the tail. And if that does happen, our p-value is also going to be less than alpha. Great, so we can actually reference this statement afterwards. Once we do our calculation, get our Z value, we can go back here and see if it's in the rejection region or not. So that's step 3, calculate test statistic. Because we have the population standard deviation, we're going to use Z. The formula for Z is Z equals M minus mu over sigma over root N. We have every single piece of information here, so we just go ahead and get it. So our sample mean M was 8.2. For mu, we're always using the status quo, or whatever is in our null hypothesis, so that was 7.4 over 0.9 divided by the square root of 16, because there are 16 people in the experiment. So quickly punch this into the calculator. We get 3.56. Great. I'm also going to go, because it's a Z value, I'm also going to do kind of our quasi step 4, which doesn't always have to be done, but I would definitely recommend it whenever we have multiple alphas. So I'm going to go and find the p-value. And all the p-value is it's the area under the curve in the tail. So I'm just going to look 3.56 up in my Z table and see what the proportion is in the tail. Looking that up, we see it's very small, 0.00019. So that's 0.019%. Not 1.9%, but 0.019%. So very small. And that makes sense because we know once Z gets up over 3, the proportion in the tail is pretty much negligible. So our last step is to actually make a decision and state a conclusion. We could see as soon as we found our Z value, 3.56, that's much greater than 1.645, which we said we would then reject. So we can say we will reject the null. So when we reject, we can say there is significant evidence. So there is significant or statistically significant evidence that the drug is better than basic treatment. If we're doing our APA format, we can say our Z equaled 3.56, which is greater than 1.645, and P was less than 0.05. Now, do we actually have to go back and test at 0.10? No, we don't, for two reasons. First, at the smaller significance level of 0.05, if we're rejecting then, that means our Z value actually fell like way in the tail here, right? Because there was hardly any area, only 0.019% to the right. So if we're in the 5% tail, we would obviously be in the 10% tail as well. So we know it's also going to be rejected at 0.10. We could also always take our p-value and compare that to any significance level, and it always follows that if p is less than alpha, we reject. So since 0.00019, so it's actually this value, don't get confused with the percent, 0.00019 is way less than 0.10, we will still reject there. We would still reject at 0.01. We would still reject at 0.005 because this is such a small p-value. And that's where the p-value is really helpful. If they ask you for multiple alphas, sometimes maybe we wouldn't reject at 0.05, then we would compare our p-value to 0.10 once again and determine if it's smaller or not. So hopefully this is helpful. Again, they give you a significance level, so you are pretty sure it's going to be a hypothesis test. And they give you the population standard deviation, so we know it's a Z test as opposed to a t-test. Hopefully this is helpful. Always email us info@arnoldtutoring.com with any questions. Thanks.